All right, guys, we're going to get started. This is pretty much the first lesson of the year. Okay, this is the first big one. Okay, the way that I've been teaching this and the way I want to explain Algebra 1 for you guys is this right here. What is that? Staircase. Okay, why would I draw a staircase? You may know what that represents. Well, it kind of represents a graph, but as we're trying to get to the top, what did we focus on when I was talking to you guys? What are we trying to get to at the end of the year? What's at the very end of the year that I really want you guys to get? It's a STAR test, right? So we're going to try to get ready for STAR. Ultimately, right now we are right here. Okay, let me draw you a little picture. This is you guys. Okay, it's a good looking stick figure. Okay, this is where we are at as a class. Okay, but what we ultimately want to do is we want to get up to this point. Now, the reason I'm showing you this is because today we're going to start from the very, very bottom. Okay, solving one-step equations and all this other stuff. Okay, now people are like, okay, I already know how to do this. Well, terrific, but I need to make sure that we fully understand it before we can try to get to what I call the top of the staircase. Okay, because when we're doing stuff at Christmas, we're still going to be doing stuff down here. When we get to quadratics, part of quadratics, we still need to know how to do one-step equations. So we just add on to the stairs. So just because we forget what's at the bottom of the stairs or just because we pass it doesn't mean we will never use it again. The thing about Algebra 1 is that we're going to continue to use what we have at the bottom of the stairs for the entire year. Okay? So all we do is we just keep adding and adding and adding and adding. Please plug that in over here. Whose Chromebook is that? Plug it in over here, please. Okay. Does that make sense? So right now we're at the very, very bottom. So even if like today is very, very simple, very, very easy to you, I want to make sure that you understand that it's going to be a staircase. And what I'm doing is building to the very end of the year. We get up here, we're going to be doing quadratics, which look like negative b plus and minus the square root of b squared minus 4ac all over 2a. That's where we're going to eventually get to. That's not where we're at right now. Makes it looks worse than it really is. I promise you, it's not that bad. Okay, but we're going to build to that point. I'm not just going to show it to you now. Fair? All right, so here we go. With your partner, let's talk through this. You have a slide. Which real-world situation is represented by the inequality? 25 plus 3x is greater than 10 plus 5x. So let's talk through these examples, okay? Now, is it asking you to solve it? No, it just wants you to figure out which situation represents that inequality. Yes? Okay, so let's talk through the first one. 25. A $25 item depreciates by $3 per year. First of all, what does depreciate mean? Goes down. Which would that be adding or subtracting? So would letter A work? No, it does not work because of that word right there. So A does not work. Let's talk about B. A store charges $25 plus $3 per item. The word per means to multiply. Okay, we're going to multiply, which looks like it. $25 plus $3 per item. That actually looks okay so far. Yes? Keep reading. Another one charges $10 plus $5, what? Per item. Okay, so we feel pretty good so far, right? Find out when the first store is what? Cheaper. Would that be greater than or less than? That's less than. What do we have up there in the equation, or the inequality? That's greater than. So guess what? Everything looked good until that last point. Okay? Last one. Somebody read the last sentence of letter C. What is tie? You see an equal sign up there? Nope. So process of elimination, my answer probably has to be D, right? So let's just check it. Account A has $25. It gains $3 per week. There's that word again. $25 gains $3 per week. Account B has $10 and gains $5 per week. Find the weeks when account A has what? More money than, or more than, or what's another way to say more than? Greater than. Okay, greater than account B. So my answer makes sense. My answer is what? D, right? So let's do another one. All right, down at the bottom, 2 booths at the carnival sell activity passes. Booth A charges $12 plus $4 per activity. There's that word per again. Okay. Booth B charges a $20 admission fee plus $2 per activity. Okay. Find the one. Now, thumbs up when you guys find it. I'm going to let you guys work individually. I'll give you about 15 seconds or so. You might be able to find it. Booth A, $12 plus $4 per. $20 plus $2 per. Find when they are the same or equal. Okay, find it real quick. Once you have it, put a thumb up. Okay, I see a couple thumbs popping. Thumbs are starting to fly all over the place, which is good. I like it. You good? If you need to, go break it down into parts, okay? $12 plus $4 per activity. Somebody open that back door, please. $12 plus $4 per activity. Okay? Yep, it's over there. I knew you'd be back. All right, which one do you guys, all at once, ready? Which one is it? It's A, 100%, okay? So you got $12 plus $4 per activity. $20 plus $2 per activity, okay? So there it is, letter A. Make sense? And they are equal, they're the same. All right, here we go. We'll get to the equations here before too much longer. We'll come back to the equations. Okay, does everybody have paper? Everybody have pencil? Everybody have something to write with, okay? Today, what we're going to do is we're going to break into, here's our goal. I can create and solve linear equations with one variable, okay? We are going to start from the absolute basics. We're going to break down one-step equations and go all the way down into multi-step equations, okay? Our TEK that we're trying to cover, which is basically what the state of Texas says that we need to teach, A5A, solve linear equations in one variable, including those for which the application of the distributed property is necessary, and so on, okay? We did distributed property last week. You guys remember doing that? We distributed and then we combined like terms, yes? All right. So here we go. We're going to break this down from the very beginning and go from there, okay? Here we go. Exploring a kayak. Joshua is going kayaking with a group during one of his vacation days. In his vacation planning, he budgeted $50 for a kayak. Okay, this is a real world situation. Okay, you're going on vacation. You got $50 you want to spend for a kayak. You walk up to the place. You can get a kayak for $15 an hour. You can get a single sea kayak for $18 an hour, just a little bit bigger. Or you can get a double kayak for $25 an hour, okay? How can Joshua determine the number of hours he can rent a kayak for himself? How can he determine how many hours he can rent for himself? What do you guys think? You have $50. You want to find out how long you can rent a kayak. How can you do that? By what? Dividing by what? Hourly rate? Okay, so how would you do that? You what? Look at the picture? What do you mean? So let's start with this one. How long can you rent a single kayak? 3 hours? That'd be $45, right? Okay. What about this one? How long will that go in? You guys have a calculator? What is 50 divided by 18? You have a calculator right in front of you. Where's your paper? You don't got one. Okay, here we go. Do you have pencil paper? Do you have pencil? Okay. Yes, sir. What'd you get? Do what? 2.8. So almost 3 hours. And how many hours can you get a double kayak? 2 hours. We know that. Now, hold on. Letter B. Let's change the situation just a little bit. But I keep spinning the wrong side. Joshua finds out that here's a $25 fee. So you walk in, you got $50. He's like, I got $50 to spend. He walks up to the kayak place. They're like, okay, we can rent you a kayak, but hey, we're going to charge you $25 before we ever get started. You're like, dude, that's not cool. But they're going to take $25. So how much money do you have left? $25. Does that change his mindset? Would that change your mindset? Yes, it changes your math a little bit, okay? That's real world situation. I could write these equations if I wanted to. We'll get to that in a minute. Okay. All right, here we go. 1 and 2 step equations. Everybody do me a favor, write down number 1. We're going to use what's called inverse operations. We're going to use inverse operations. Okay, somebody do me a favor. Tell me what the inverse of adding is. The inverse of adding is subtracting, right? I'm trying to adjust the camera just a little bit. There we go. The inverse of adding is subtraction, yes? Okay, what's the inverse of multiplying? Dividing. Okay, so that's how we're going to solve these problems, okay? We're going to have adding, we're going to have subtracting, we're going to have all these different kind of problems. But you're going to use inverse operations to solve equations, okay? Basically, it's backwards PEMDAS. We're going to get to that in a minute also, okay? All right, so here we go. X plus 15. So here's the way I always do it when I'm starting out. Put like a T right through the equal sign. Go ahead and do it. Step by step, please. Put a T right through the equal sign. Now, I always like to put a box around the X, just like this. Now, what that tells me is that's the side that I'm going to do all my work on, right? Because what letter am I solving for? X. That's ultimately what I want to solve for. So all of my work is going to be done on that side of the equation. Yes? It's going to be done on that side of the equation. Okay, so if I have plus 15 here, how do I get rid of plus 15? What's the inverse of adding 15? Subtracting 15. So if I subtract 15, what that does is that cancels that out, because what's 15 minus 15? You just canceled it out. Now here's the deal. If I do something to one side of an equation, you have to do it to the other side. Because right now we have what's called a balanced equation. Yes? You have a balanced equation. And what you're going to do is if you do anything to one side of an equation, as long as you do it to the other side, you're just fine. But you have to do it to both sides to make it work. You can't do something to one part of an equation and not the other side and expect it to work out. Even if you do it incorrectly, you can actually get back to the correct answer. If I multiply this equation by 100 on the left side, as long as I do it on the right side, I can still get back to the right answer. As long as I'm doing it to both sides, I'm still okay because the equation is still balanced. Does that make sense? But if you do something to one part of an equation, even if it's wrong, do it to what? Do it to both sides, okay? Always remember that. Do it to both sides. So if I subtracted 15 here, I'm going to do the same thing over here, minus 15. Somebody read this math problem to me right here. Negative 3 minus 15. Somebody, you guys have a calculator, right? What's negative 3 minus 15? Negative what? Negative 18. There's my answer. So if I plug it in, if I wanted to check my work, negative 18 plus 15 is negative 3. That seems logical to me. Okay, you want to try another one of those, just adding, subtracting? Okay, do me a favor, write down number 2, go ahead and solve it, go. Now it's worded, it kind of looks a little bit different, looks a little funky. Wake up, please. I'd hate to have you stand the rest of the class. It's a little funky, it's worded a little bit different. You got y plus negative 16. What letter am I solving for? Because I want to know. Okay, never mind. So stupid. Math humor. All right. So if I'm solving for y, I got to get rid of what number it's over there with the y. Negative 16. What's the opposite of negative 16? I'm going to add 16. I know it's a little bit different, okay? Go ahead and do it. So you told me the opposite of subtracting 16 is adding 16. So I'm going to add 16 here. What's 9 plus 16? Y equals 25. Perfect. Good. How are we doing on adding, subtracting? Is everybody okay? By the way, this one right here, I know it looks funky, doesn't it? I call that funky, okay? I could have written this problem exactly like this. What's the difference? Do what? There's no parentheses, but is the problem different? No. What kind of 16 is this? That's a negative. What kind of 16 is this? It's just worded a little bit different, okay? 5 minus 2 is the same thing as 5 plus negative 2. It's the same problem. It's the exact same thing. So don't let, if they want to do something like that with you and just kind of mess with your brain a little bit, don't let it mess with you. You're still getting rid of that specific number. Does that make sense? Please do not let that little confusion mess with you, okay? All right, let's go to number 3. Negative 3m equals negative 9. Write that down, please. What operation is a number next to a letter? Multiplication. So I'm going to have you guys write this down, okay? Like 3x or 3m. Okay, please write that down. That is multiplication. Okay? That is multiplication. If you have m over 3, that is division. And what's the opposite of multiply? Divide. You would divide to solve it. Okay? That's how you get rid of it. Why can I not do this? Why can I not add 3? Does anybody know? We learned this the other day. Why can I not add 3? We talked about it last week. You combined what? Like terms. Those are not like terms. You can't add 3 to 3m. You could add 3m to negative 3m because they match, right? But you can't add. Now you can multiply, you can divide, you can do all that stuff, but you can't add. You cannot do that because they are not like terms, okay? It does work up here because 15 and negative 15 are like terms. They're both constants. What's the word constant mean? That's another word. Write that down. Constant. What's a constant? It doesn't change. It's just a number by itself. If I have a $5 bill in my pocket and it's constant and I don't do anything with it, when I walk out the door, how much money should still be in my pocket? $5 bill. Nothing happened to it. I'm not multiplying it. I'm not subtracting. I'm not doing anything. 5 is still 5. Okay? All right, here we go. So I can't do that. This is multiplication. So how do I get rid of multiplication? What's the inverse of multiplying? Dividing. So here we go. So I'm going to divide. What's the opposite of multiplying by negative 3? Dividing by negative 3. We don't change the signs. The only reason we change the signs on adding, subtracting is, let's do it again. What's the opposite of adding 5? You just change the sign by knowing that it's opposite. The opposite of adding is subtracting. Yes. The opposite of multiplying and dividing is dividing, but you don't change the signs, and I'm going to show you why. Okay. So I'm going to divide by negative 3. Yes. What that does is that cancels it out. But if I do anything to one side, I got to do it to the other side. What is negative 9 divided by negative 3? Positive 3. M equals 3. Now check this out. Hold on, just one more thing I want to show you on this. When you canceled out that M, okay, when you canceled out that negative 3, you divided the number by itself. Yes? You divided by itself. When you divide it, if you divide anything by itself, what do you get? 1. What's 5 divided by 5, guys? 10 divided by 10. Negative 3 divided by negative 3. If there's no number on the front of a variable, there's actually a 1 there. You never see 1x, do you? You never see it. It's there. I promise you. It's not 0. It is not 0. It is 1. Everybody understand that? Please learn that now. That will help you later on, okay? Everybody good on this? Cool. Solve this one, please. 2x equals, let's go 18 really quick. Go. Should not take you very long. Kind of the same problem. All right, Jordan's doing a good job. She's doing a lot of talking. So somebody else, I want to hear from somebody else. What do I do? Oh, see, this is the problem. Nobody wants to talk now. Divide by what? Yeah, I'm just going to divide by 2. Divide by 2. X equals what? Perfect. Simple. All right, let's go to number 4. Write down number 4, please. X over 4 equals 7. X over 4, same thing. Don't listen to what I say. Listen to what I mean. X over 5 equals 7. Huh? You all right over there? Yeah. Dude, if you need to stand up a stretch, stand up a stretch. Okay? Hey, I do the same thing. Like, we have teacher meetings. I'm not kidding. I can get up, stand in the back, just get some blood. Okay? I won't. Do I seem like the guy that's going to get mad because you stand up in class? No. Yeah, stand up and get some blood if you need it. Okay? That's for anybody, by the way. If you want to stand up and stretch, cool. Stand up and stretch. I don't care. All right, here we go. What kind of problem is a fraction? What is that? Somebody else? It's dividing. It's division. What's the opposite of division? Multiplication. What's the opposite of dividing by 5? Multiplying by 5. Good. So I'm going to multiply both sides by what? By 5. Have you guys seen it like this, where you multiply both sides by 5? Is that how you saw it in middle school? Yes? No? Not at all? Okay. All right, so I'm going to show you a different way, okay? Now, it's not wrong. It's just kind of a little math trick, okay? Anytime you have a fraction, here's a good way to get rid of it. And we'll come back to this in a minute. Just multiply across. What's 7 times 5? 35. And whatever's on top comes down. X equals 35. We're done. So I see a lot of nodding. Like, I kind of like that. A little math ninja voodoo stuff going on. Nope. Okay, everybody good? Math voodoo. Okay, so let's do this. X over negative 4 equals 3. Go. Solve that one really fast, please. When you have an answer, just put your pencil down so I know you're done with it. Did you get it? Did you already solve it? Okay, you writing this stuff down? Yeah. Cool, thank you. Now, we're not going to go on to number 5 and number 6. That's talking about reciprocals and whatever. We'll do that later, okay? You may know what a reciprocal is, by the way. A reciprocal is just a flipped fraction. Like, what's the reciprocal of 3/4? 4/3. Seriously, that's really all a reciprocal is. We'll get to that later, okay? We will talk about that later. All right, what's the answer? What's negative 4 times 3? X equals negative 12, simple. Because if I plug that in, what is negative 12 divided by negative 4? What's 2 negatives? Positive 3, so it works. Okay, it absolutely works out. All right, here we go. Let's go to two-step equations. Everybody ready? We're doing backwards PEMDAS. Okay, we talked about PEMDAS last week. Okay, remember our first day where we actually did work in here last week? Everybody's like, why are we working? I said this is going to tie into what we're doing next week. Well, here we are. Okay, we are tying into what we did last week. Okay, what is the P? Parentheses, exponents, multiply, divide, add, and now when we're solving equations, what you're going to do is you're going to work backwards. Okay, when you're solving two-step equations, you're going to get rid of your adding and subtracting. In other words, you're going to get rid of the constant. So let's talk about this. Somebody, you guys write down number 7. Go ahead and write it down, please. And we are going to get rid of the constant first. The constant first, okay? What did I say the constant was? The number that wasn't real, nothing was going on with it, right? So if I do this, I do my little T square, whatever you want to call it. I had a teacher in like years ago that called it like train tracks. Like, that does not look like any train tracks I've ever seen. Okay, makes no sense. All right, here's my X, yes? So all of my work is going to be done on that side. All of my work is going to be done on that side of the equation. So if my X is on this side, that's where all my work is going to come from because I'm trying to solve for the X. Does that make sense? Your focus should not be on the other side at the negative 7. That's where everything's going to go. Okay? Solve here. Dumping ground is over here. That's the way I always kind of looked at it. This is what I solved. This is where I put everything. Okay? So here we go. What number is kind of just by itself? What's my constant number over there? The 9. Okay? How do you get rid of positive 9? Subtract 9. So let's subtract 9 from both sides. Because that's what I do like the T because it shows me that I have to do it on both sides. Yes, sir. No, sir. That's all I'm done. All right. I'm not big on bathroom breaks while I'm in the middle of a lesson. Okay, but after I'm done, I will let you go. Okay? All right. So we've got 2x equals, I've got a negative 7 plus negative 9. What is that? Negative 16. Jordan's in here killing it. Okay. Negative 16. Now, a number next to a letter, somebody other than Jordan. What is that? What operation is that? That's multiplication. How do you get rid of multiplication? You divide. What are we going to divide by? Perfect. We're going to divide by 2. Divide by 2. And if you notice, what do we do first? We did the add and subtract first. Now we're doing multiply and divide. That's the way it usually goes. Fair? We're going backwards. What's negative 16 divided by 2? Negative 8. All right. Clear as mud? We're okay? Clear as Dr. Pepper. Everybody's good, right? Wakey, wakey. You okay? I know it looks like you're starting to droop a little bit. Everybody's thumbs up? Okay. Let's do let's do another one of those just for the heck of it. Don't worry about this problem, okay? Let's go negative 3x plus 5 equals negative 13. There we go. Negative 13. Sorry, I don't want it to be a decimal. That's why I was kind of thinking through numbers. It shouldn't be a decimal. I tried that yesterday and it came out to be a decimal anyway. Fix my beard in the camera. All right. All right, let's do some popsicle sticks just for the fun of it. Let's do some popsicle sticks. I like it because it's completely random. And it helps me learn your names because we're very, very early in the year. All right. Number 10. Who's desk number 10? Number 10? Think so? Tell me your name. Kaylin. All right. Give me the first step. Yeah, we're all in the same boat. So if it's a little bit confusing, we're going to work on this together. Here's my X, yes? Yep. All right, what number's on that side that I can move easily? Like, use this one as a guide. What did I do first? What would I do on this one? Perfect. We're going to subtract 5. Thank you for playing. Subtract 5 from both sides. Guys, what's negative 13 minus 5? Negative 18. Negative 18. Perfect. Thank you very much. Good job. All right, next one. Number 1. Sweet. All right, Aaron. No, you're going to tell me the steps. What do I do now?
You got to divide.
Yes, sir.
Yeah, you got to divide the -3 by 18.
Not by 18.
Like negative.
-3 into the 18. Yes. All right, you're on the right track. Is this what you meant, like this?
Yeah.
Perfect. Okay. You're going to divide negative 18 by -3. So basically, you're just dividing both sides by -3. So what's my answer? It's just 6. Negative 18 divided by -3 is positive 6. Everybody good? Cool. Everybody write down number 10, please. Write down number 10. Number 10. Do me a favor. Make the little T thing. Put a box around the X. That's the side all the work is coming from. The first thing I'm going to do is either add or subtract. Okay, go ahead and start on it. Go ahead and start it. I see a lot of people writing, which is good. Hey, while you're working really quick, do me a favor. Just put up real quick, just 1 to 5. Show me where you're at right now while you're working. I'll just kind of look around. I'll tell you when I got everybody's number. Okay, see good numbers. Okay, keep working. It's good. My head looks really big in that camera. Okay, that's all right. All right, so here we go. What do you think, guys? The what? Give me the steps. Nope. We're going to do this. There's my X, so all my work's going to come from that side, yes? What's the opposite of negative 5? Positive 5. So I'm going to add a 5 to both sides. Plus 5, plus 5. So what is negative 2 plus 5? Positive 3. So now I bring down everything that's not canceled. X over 3 equals 3. X over 3 is what kind of problem, guys? It's division. What's the opposite of division? Multiplication. So I'm going to multiply the next two numbers over. So what's 3 times 3? 9. X equals 9. We're good. Everybody good? Like I said, we'll get to the fractions later. Okay, we'll worry about the fractions later. All right, let's do a couple more. Yes? Are you guys feeling pretty good? You feel like you guys have done this before, yes? You have. Okay, so it's kind of good to go back over it. Okay. All right, let's do, I'm going to let somebody pick one. Desk number 18. Yes, sir. Tell me your name. Ian. Okay, pick 13, 14, 15, or 16. Just pick one of them. Number 16. Go. You guys write it down. Nah, it's not the hardest one. It's just backwards. Hey, can I give you a little hint? If you don't like the -7 equals, just write that and just go equals -7. Just work from this side over. You can flip it around. It doesn't really matter. It's the same problem. Now the whole problem is a fraction, right? You guys remember a minute ago when I told you guys what you could do, the little math voodoo ninja stuff? How to get rid of a fraction? What did I tell you? Multiply across. And bring whatever is on top down. Sound familiar? A little math voodoo ninja work going on. Yes? You all right? Stuck a little bit? I got you. All right, so if we got that, bring it down with it. So what's 4 times -7? Multiply this number times that number. What'd you get? Perfect. So here's what you got. Thank you for playing along. Here we go. So here's what we're talking about. When you have these whole problems that are fractions like this, yes? Is everybody focused on me? I'm gonna give you a little trick. Hopefully you're watching. I'm just gonna take this and I'm just gonna multiply across. What's 4 times -7, guys? -28 and whatever. Well, that's okay. There we go. And whatever's on top can come down. 5 plus a. Whatever's on top of that fraction can come down. Yes? Now, what number can I move? I'm still solving for a. So what number now has to go? 5. What's the opposite of +5? -5. So -5. What does a equal? -33. There it is. Let's do one more. One more. Fair, and then we'll be done. One more problem. Who wants to pick? 19. Who's desk number 19? Which one would you like to do? Tell me your name. Huh? Leslie. What number would you like to do, Leslie? Number 13. You guys, let's do number 13. Go. I'm going to leave this one up here for you. It's kind of a guide. I'll give you a few seconds to work. Again, I'm going to pause the screen. And we're back. Okay. All right, so who wants to... All right, well, let's just do the popsicle sticks. Here we go. 22. All right, tell me your first step. What's your name? Nico, tell me the first step.
Multiply 5 and
What'd you get? -15, and then what happens?
then you subtract 7.
Well, I want to bring down the x plus 7. Right? Now, somebody else. Let's do it. Well, 29 is too many. 23. Well, I'm going to go with you. Go ahead. You're not there? Okay. That's all right. Number 6. You're not done? Well, let's talk through it. Okay. Well, I already kind of have it up here on the board for you. So what's the opposite of x plus 7? Yeah, I'm going to subtract 7. Perfect. We're going to subtract 7 from both sides. So we're going to go -7, -7. So we have x equals 2 negatives. I'm going to add them together and keep the sign, right? It's like being underwater, and I go down even further. If I'm 15 feet underwater and I go down 7 more, where am I at? 22 feet underwater. Okay, that's the way I always think water when I'm like negatives. It's easy. 15 feet underwater, down 7 more. Where am I going to be? Okay, everybody good? All right, good. I'm going to give you guys a small break. You need to get your Chromebooks ready, get your Chromebooks set up, and then we're going to go into our work, okay? Hey, if you like the video, like it, share it with your friends, okay? You click like and subscribe. Okay,